Alright, this is my video 2 for the Centipede final sprint submission. For this video, I'll be talking about the managers both for the critter and the centipede, and I'll explain the centipede body and head as well as the movement function, and then talk a little bit about the mushroom field and the mushrooms inside of it. So if we're looking at the managers, first we can look at the critter manager, which is inside the strategy. The critter manager is a singleton, and we have the set data function. So whenever we call set data from the wave manager after reading, we'll grab the wave data struct, which has all the values for that wave number, and then we can set our data equal to that wave data. So we have those values spawned, and then we can call private start spawn, which will start the alarms for the spawning at the given spawn rates that we loaded in from start spawn or set data. And then we have the alarm 1 and alarm 2, which are for spawning the scorpion and the spider at the different values and speeds. And then we will push those to a stack of spawn critters, which is used to call delete on all of those for clearing the screen. The flea works a little differently in that anytime a mushroom is destroyed, the mushroom manager will send the value that equals how many mushrooms are in the player bounds, and if that meets the requirements for a flea spawning, then we will spawn a flea and keep track of the fact that we have spawned a flea so that any future calls can be ignored. And then anytime a flea dies, we'll call back to the manager, and then we'll check again if the amount of mushrooms in the player bounds is still enough to meet that requirement, and if so, we'll spawn a flea again, and then we'll end up looping back here when the flea dies. Or if we've spawned enough mushrooms and the requirement is no longer met, then we won't spawn anything and that loop cycle will end. But down here we have the two updates, which just call back whenever the spider or the scorpion die, which stops the sound, and then we'll reset the alarm. And then in our clear screen, just run through all of the critters that we've spawned and call delete, which will just remove them without score updates, and then we'll cancel the alarm for the spider and the scorpion so that no future spawning happening. And then we'll, on terminate, just mark for destroy the object and empty out the stack of objects that we spawned. And then we can look at the centipede manager. Which the centipede manager has a similar set data function that will just grab the appropriate values from the wave data struct and set them inside of itself. And then in our start spawn function, we will spawn a centipede and give it the appropriate amount of body segments to spawn. And then if there's any solo heads to spawn, then we will spawn them at the given position without any segments. And then anytime a centipede body or head dies, we'll call back with purport death so we can decrease the count. And then if there are no more centipedes on the screen, we can stop the sound and we can call for wave clear since we have beaten the wave. Report delete is for when we are calling clear screen to delete centipedes. We don't want to be checking for wave clear, and we don't want to do any sort of score requirements. Report spawn is used since the manager will only ever spawn heads. Then these heads will spawn segments, so whenever a segment is spawned, it will call the report spawn function to add it into the total count. And then report split, anytime a new head is created, we will grab a reference to that head, since that is what we need for clearing the screen. Because then when we call clear screen, we will call delete on all of the spawn centipede references in this stack, which are all heads. And then if the heads have any segments, they'll call delete on those, and that delete command will chain down through the body segments. So if we look at the Centipede itself, we have the Centipede header file, which has data that is shared amongst the body and the head that is just declared here to avoid repeat declarations. And then we have the delete function, which is just overrided, which is just a function used to remove the centipede's bodies and heads without any score commands. But in the head, we'll initialize with the value that tells us how many segments we have. And if we are spawning with any segments, we'll end up calling spawn segments on that length. And in spawn segments, we just go through and we'll create a linked list of next and previous nodes that are, each node would be a centipede body that we spawn at that position. And then inside of our update, we're just updating with our FSM offset values, and then we rotate with the appropriate rotation value that we have in that offset. And then anytime we finish a movement, if we have a segment, then we'll call movement update on that segment, giving it our current movement, and then we will calculate our next movement based on our values in the grid. And then anytime we die, the main thing is that we'll be calling, if we have a next segment, we'll call head death and next, which will be responsible for the splitting. So if we look at the body, all of the bodies initialize with count of 0, which means they won't do any sort of movement. And then we pass in a bool HD telling whether or not we are the second segment, so we know whether or not to use a head or previous pointer, depending on what is in front of us. So inside the update, since the count is 0, initially we won't call any of these position updates, so we won't move. But then when the head finishes its first movement, it'll call movement update, passing the move state that it just did. And we will set that to our move state, and we will set our count, so then we will move doing the move state that the head just did. And this active bool is initialized to false and then set to true after the first movement. So that way, only on the second move do we call for the head or the next segment to move, which basically means that every segment will do one move before it calls the next segment, which allows the segments active to domino, and they'll activate one after another. And then, so anytime the head is killed or a segment is killed, head death will be called in the next segment in the list, which just sets headless to true. And then anytime we finish a movement, if headless is true, then we will call become head, wait to finish the movement so that we stay within the bounds of the grid. But inside become head, we just spawn a new head at our position, and we give it the next pointer of the segment behind us, so that it is connected to the rest of the centipede, and we just report that split and set the appropriate values in the next centipede, and then we mark ourselves for destroy. And then looking in here in this delete function is what I was saying previously, that if the head calls delete on a segment, if there's a segment after you, you will call delete on that as well. So the clear screen command will start with the head and then move down through all of the segments. But then looking at the mushroom field, so the mushroom manager has 3 grid data values in it: the AI player 1, player 2, and a pointer to of current grid, which is referenced to one of those. And so in grid start, we'll run through and spawn mushrooms, 2 random mushrooms in every row in a different column. and then we'll call private mushroom spawn, which will then spawn the mushroom at that position, and then we'll call grid update, which will add that pointer into the mushroom pointer array. But one of the big things is this grid data, which has an int array of stored ints. That's the size of the grid. It's just zeros and ones, and then an integer of trigger shrooms. And so anytime we add a mushroom into the grid, we'll call set data at that position. And if that position is in the player bounds, we increase trigger shrooms. And then anytime we delete a mushroom, if that's inside the player bounds, we decrease trigger shrooms. So it effectively keeps track of how many mushrooms are in the player area. And then anytime we want, we can call get trigger to get the value for how many mushrooms are in the player area. I'm looking here, and then this grid delete function will just make sure to null out the pointer in the mushroom array so we don't have references to mushrooms that have been destroyed, and we'll call the clear data to reset the value in there, which will decrease the count of mushrooms in the player area if it's applicable, and then we will test in the flea manager or the critter manager whether or not a flea should be spawned. And then in the mushroom spawner, I didn't mention this before, but this function or line here is just to make sure that you never spawn a mushroom on a spot that there's already a mushroom, and we don't spawn a mushroom above the top mushroom row. And then the check grid function is just used to check values at a different position. And if there is a mushroom at a position that you're looking at, we just call return status, which will return either 1 for a normal mushroom or 0 for a normal mushroom and 1 for a poison mushroom. And then switch grids isn't used since 2-player is not implemented, and then clear grid is just used to reset the array of pointers anytime you wipe the grid. And then field regen, whenever it's called, will run through the grid of mushrooms from the top right down to the bottom left, and it will grab any mushroom that is damaged or poisoned and add them into a stack. And then depending on if there are mushrooms in that stack, we'll set the alarm at this value, otherwise we'll set it here just to delay even if there are not mushrooms, so it's not an immediate transition. And then we'll just run through the stack of damaged mushrooms, calling regen, and then looping back until it's finally empty, and then we'll call regen complete once it's done. But the mushroom grid also contains blocks which are used as invisible mushrooms for blocking under glyphs, and that is just spawned in the private report block, and they are just added into the field array at a position, and they're mushroom pointer casted, and since they override functions from the mushroom, it still works inside the check grid since those functions are overridden within the block. Where's that? Right here. So the return status will always return 0 as a normal mushroom since it's been overridden inside the block function. So it will always return normal.